Hornets, and welcome. Today we're going to be taking a look at how do we use the slope fields in order to draw a curve. Now, in this section, there are several components. Number one, you have to make a slope field. Number two, you have to use the slope field to make a curve. And number three, you have to find the particular solution based upon the information given that creates that slope field. And if you recall, when we were creating slope fields today in class, we were using the dy dx at individual points. Now, it is my intention to go through first using the slope field to graph a curve, then how do we make a slope field, and then how do we find the correct dy dx given a slope field. So that's my intention. And if all goes well, we'll be able to get this done within 1 or 2 videos. So let's go ahead and start with this first one. This is a basic, straightforward problem where we are being asked to do 2 things. Well, actually 3. Number 1, they want us to draw a curve. Number 2, they want us to find another point and draw another curve. And 3, they want us to find the particular solution by solving the differential equations that we have on the page. Notice the condition is 2, 2. That is our initial condition. And that's the point sitting over here. Now, if you recall, the police, they're kind of like our guide, okay? You know how if your parents are driving you around and you come to an intersection that the lights are out, usually there might be police officers guiding the traffic to make sure that cars don't run into each other. Well, that's what these lines are. These lines are the police officers extending their arms horizontally out. And your job is to avoid hitting the police officer. You can go right by them, but you can't run through them. If you run through them, then you're going to lose credit. So let's take a look. If I'm starting up here, I'm at a horizontal, and I'm going to turn. And I'm going to try so that this becomes kind of like a tangent line. See how it forms a tangent there? Well, as it comes down, I'm going to go in between, and I'm going to try my best to use the curves without making any radical or steep angle changes. So we're always trying to be within about 15 degrees of the line segment and be parallel to it. Now notice I'm going up. I'm coming to the other side. Now where it's parallel, right across the other side, we're going to make sure we do a tangent. This is now my approximation of the curve. Let's go ahead and choose a point up here. There's my point on that side. Start with the tangent line, making a tangent, then curving down, curving across, coming flat, so it's parallel to that. And now I'm moving back up again. A little bit skewed there. Let's make it not quite so steep. Coming up, and making another tangent. Notice both of these curves, as I have drawn them, look fairly similar to each other. They are supposed to. That's because they're both using the same dy dx at the various points. They can't help but be similar. Let's go ahead and take a look at now finding our particular solution. To find the particular solution, always start by rewriting dy dx exactly as it's written on the page. Don't try to be fancy. If you try to avoid certain steps, you're going to lose all of the credit on the AP test. Now separate your variables. Don't put the integration in yet. Remember, 1 step at a time, so that on the 3rd step you use the integration. We're now going to have to use a u substitution here, just as we've seen before. We're going to let u equal 4 minus x squared, so that my du is negative 2x dx. The negative 2 is not present, so it has to move to the other side, giving us negative 1/2 du equals the x dx. We can now do our substitution, giving us y equals the integration with the negative 1/2 in front for u to the 1/2 du. Now when I integrate, I add my power of 1. This is giving me 3/2, so I have y equals negative 1/2 times 2/3 u to the 3/2 power plus c. The 2's will reduce, and y is now negative 1/3, back substituting my u. 4 minus x squared is to the 3/2 power plus c. Now, we're not looking for a general solution, we're looking for a particular solution. So I'm going to have to figure out what is c. To do that, we're going to take the point 2, 2. So y is equal to 2, and I substitute directly. X is also equal to 2, and we're going to substitute it directly. Notice that I get 4 minus 4 is 0, times negative 1/3 is 0, plus c. That means that 2 is c. And I can now rewrite my equation, putting c in as 2. This is my particular solution that I'm looking for and what we're trying to do. Alrighty, let's go ahead and see, how do we make a slope field? Now, in order to make a slope field, what we have to do is look at all of these little points. See how all these dots on this page? They're all representing coordinates, and each of these coordinates is a designated position. Notice that dy dx is a negative 1. That means that for each of these dots, we are going to make a small segment that is equal to a slope of negative 1. And it goes all the way down the page. Once again, don't make life hard for yourself. Just slide over and do it. Now, you'll notice that the segment's length, there's no clear delineation for how long it has to be. It just can't be across the whole page. If that were the case, it'd kind of be a little silly. And I'm going to make sure that I put a point, this slope, at every single point that I have on this page. That's what a slope field is. And you'll notice it's fairly easy to make. It does get harder as we move on, but you can see it's pretty clear. And there's our slope field where dy dx is always negative 1. Look at number 2. We now have 1 over x. So if I use x equaling negative 1, you'll notice I'm going to get a negative 1 slope. But if I use x equals 2, I get a positive 1 slope. If I use x equals 2, I get a 1/2. And if I use x equals negative 2, I get a negative 1/2. And you'll notice it's always going to be consistent all the way up and down. We do not have anything on the y-axis because that's where we have a vertical. Now, occasionally you will see vertical lines. We look for them if they are present, because the vertical line means that my x value was in the denominator. Please do not put anything at the origin. This is important because we would have a 0 over 0. All right, let's go ahead and find negative 1 first. So we're going to do our negative 1 slopes. Negative 1 here, 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 and here. Positive 1 slopes on the opposite sides. So positive 1 here, 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 and here. Then we have 1/2, negative 1/2. Once again, all the way down the page. Always going to be parallel lines, no matter how we do it, all the same. Negative 1/2, positive 1/2. Find a positive 1/2. I'm going to draw them all the way down the page again. This is how we do it, over and over and over again. Let's take a look at number 5, where we start to see something a little bit different. So if I have a negative 1 for my x, and I have a positive 1 for y, I have a negative 1 slope. If I have a positive 1 and a positive 1, I have a positive 1 slope. If I have a negative and a negative, I still have a positive 1 slope. And a negative with a positive is a negative 1 slope. Notice that the zeros are always when y equals 0. So going across, when y equals 0, we're going to have a horizontals here and here, here and here. We have verticals. We don't want 0 over 0, so we have a vertical at that value and that one, here and here. We're now going to go ahead. Notice this is going to also be a negative 1 slope. Negative 2, positive 2. And vice versa, 2, negative 2. Positive, positive 2. Negative, negative 2. Alrighty, here's my slope field so far. I'm now going to have to try this point here. Notice it's 1, 2. That's a slope of 2. Over on this side, negative 2. Positive 2. Negative 2. Then we have over here 1/2, positive 1/2, negative 1/2. Positive 1/2 and negative 1/2. And here's my slope field. This is how we make our slope fields. That's what we're doing. We're taking each point based on the coordinates that we have. Negative 1, 2. We're plugging them into dy dx, and it is giving us a slope that we can approximate. And we continue with this. Now, as you're looking at these, be aware that if we have our y value, see how our y value is creating a constant slope all the way across? That means that our y value is going to be the main piece here. Notice that this slope going across, okay, let's just check and see what it is. That slope is a negative 2. See how it's going down 2 over 1? So I know I have this negative 2, but my y value that's creating the 2 is a positive. So I could have negative 1 times negative 2. Right? That's a possibility. Let's see. But it looks like positive 2 for the y will give me a negative 2 all the way across. 1 gives me a negative 1. Notice that the negative 1 for y gives me a positive 1, and the negative 2 for y gives me a positive 2. My answer has to be D when I'm looking at the slope, because I'm comparing what's happening. Going across, we're just dealing with the y's. Going vertically, as we saw in number 2, we're dealing with just the x. Okay? If it's dropping down as y gets larger, it's a fraction. If it's going up as the x gets larger, it's in the numerator. Let's take a look. Here we have the y values, all the same again. So it's basically dealing with the y. Here's a 1, but notice at 2 it's a half. This has to be C as my choice. Alrighty, so Hornets, this is what we're going to continue to work with tomorrow as we continue to practice slope fields. I hope this has helped you. If it has and you feel that this was a good video, please click like. If you think that there are things that I can do to improve it, please feel free to give me comments. Thank you very much. Please be well and be safe and take care. Thank you and have a great day. Bye-bye.